Namaste children, welcome to the next session on rational numbers. Irrational numbers put together, we call it as real numbers only. So the real numbers, the set of real numbers has got two major sections. One is rational number and the other is irrational numbers. Now in the rational numbers we have got numbers which can be expressed in the form p by q. And irrational numbers, we have got the numbers which cannot be expressed in the form p by q. When do we come across such numbers? When we attempt to find the square roots of some non-perfect squares like root p, root q, like that, where p and q are non-perfect squares and numbers are like this, the decimal numbers like this, some whole number, and then 1, 2, 3, 5, 4, 6, etc., 0 like that. We don't know to what places it will go and when it will terminate. So that type of numbers expressed in the decimal form, they are called irrational numbers. Obviously, these two types of numbers cannot be expressed in the form p by q. Okay. Now, in the rational numbers, set of rational numbers, the properties. When you add, subtract, multiply, divide, you will get another rational number. Whereas, in irrational numbers, it is not so. It is may or may not be. So, these properties you had studied in your lower classes, maybe in 9th standard you had studied all that. So now we will focus few more properties on irrational numbers, and one such thing is Euclid Division Lemma. That is, it is more or less the same analogy about what you have studied in your lower classes, division algorithm. Okay, what is division algorithm? A dividend is equal to quotient into divisor plus remainder. That we will be studying in detail, and its practical uses which has been founded by Euclid. Therefore, the statement is given a name as Euclid's Division Lemma. That is, we write Euclid's Division Lemma as a number a, or in other words, a real number a is equal to bq plus r, where a, b, q, r, if you take integers, they are all integers. And how are they? Now, this r, some number multiplied by some number of times, plus one more integer r, where r is nothing but 0 is less than or equal to r is less than b. Now, if you look at this, it has got an analogy with division algorithm. Now you take any number, for example, take 4. Now 4 we can write as, what are the obvious divisors of 4? We can have 0, 1, 2, 3, 4, 5 divisors we can have. Okay. Now obviously we cannot divide any number by 0, so let us not take 0. Now if you take 1, how do we rewrite 4 here using this statement? Is your first thing you have to think. Now 4 is equal to, how many, we are going to divide it by 1, say. So you can write 1, how many times you can divide? 4 times we can divide, plus 0. So 0 is less than or equal to r means that 0 you can take. Are you understanding? And this r value is less than b. Yes, r value is less than b. Is it tallying? Okay. Now next, 4, second divisor we are taking 2. So 2, how many times we can divide 2? 2 times. And what is the remainder? Remainder is 0. Okay, so that is also matching. We are dividing 4 by 2 so that we get the quotient as 2. So quotient into divisor plus remainder is equal to 4. Now next we are going to divide 4 by 3. So 3 into, how many times we can divide 4 by 3? Only one time. So the remainder is 1. Now see, this takes the value less than b. R is less than or equal to 0 is less than b. So it is taking a value less than b. Now we are going to divide 4 by 4 itself. what will happen? 4. How many times we can divide? Only one time. What will be the remainder? 0 is the remainder. So like that we will be able to fit all the numbers in this form. Therefore, it is the very basic principle that you have studied in your lower classes as division algorithm, which you are going to study further, okay, about that in your following classes. Are you understanding? We are going to bring the analogy between the division algorithm and also the Euclid's division lemma. This statement is very important. Okay, so there are given A, B, Q, R are some integers, which is always possible to fit the numbers in this format where A, B, Q and R are all integers. Are you understanding? I will give the formal definition of Euclid's division lemma. You can take it down and we will try to fit in with all the numbers that you know. Any number can be written in this form. Now there is one doubt. Somebody is asking, can we write with a number greater than this number itself? Yes. Why not? I'll show you. Now 4. Okay. So suppose if 4 is going to be divided by 5, say. How many times we can divide? We can divide 4 times, 0 times. Then what will be the remainder? 4 is the remainder. Are you understanding? Still we have got a B. R is less than this B. Are you understanding? Is it clear to you? So this is how we can rewrite any number in this format. Okay. Now more detail I will explain to you. Now Euclid's division lemma is written like this. Lemma means statement. Is a proven statement. Okay. It is given like this. Given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R, where 0 is less than or equal to R is less than B. Okay. Now this is what, when we frame the statement, we don't categorize the values of A and B as this and that. It is an integer, positive integer. And then the R and B. So R is an integer, B is an integer, 0 is a 0 integer, and R is taking the value, that is 0 is less than, greater than or equal to 0, but at the same time it is less than the value B. Okay, are you understanding? Now a simple, I am not to be very clear to you, I will show you a division sum, just like I show. For example, you take 11. Now 11 you are going to divide by 2. So you all know what is the quotient. 5 is the quotient, 1 is the remainder. So why would we write 11 is equal to 2 into 5 plus 1, correct? Now you try to fit this with that. So here A has taken the value 11, B has taken the value 2 and Q has taken the value 5. How? The format is, here the one that is going to divide, the divisor is the first number and 5 is the number of times it divides, namely the quotient, and then you can write the remainder as 1. So this is how we arrive at various results. That is, any number we can write in this format. Now I want you to divide 12 by 5. So based on that format, how will you write 12 is equal to, how many times we can divide by? It is 2 times 5 is 10. So 2 quotient or remainder. Okay. 2 quotient and 2 remainder. Okay. So how do you write it? 2 into, we are going to 12 is, we are going to divide by 5. So 2 times we are going to, so we cannot write 12 2 into. When we are using that format, the one which is going to divide should come first and the quotient should go in the next as the value Q. Plus, what is the remainder? 2. So 5 into 2 or 2 into 5, even though they are the same, The first number obviously represents the divisor with which we are dividing, and then the second number represents the quotient or number of times we are going to divide, plus 2, the remainder. Okay, now if you try to fit that, the number r, the remainder r is definitely greater than 0. Isn't it? 2 is greater than 0. And it is less than b. b is the divisor which is dividing. So this is what we have to learn thoroughly. So this is nothing but something new, or the old concept we are writing in the now matured format we are writing. So why are we studying? This is going to be useful for finding the LCM and HCF of the numbers, which you are going to study further. Okay. Now a small drilling. I want all of you to try this. Try these numbers 23 and then 14 in this format. I'll give you some time for you to think. Okay, you try. I want the number 23 to be written in this format, 14 to be written in this format. Come on, 2 minutes time I'll give you. I hope you are very seriously working. Very good. Do you understand what I asked you to do? You have to write the numbers 23 and 14 in the format of Euclid's Division Lemma. That is your first exercise. Just I want to test whether you have understood or not. Okay. Shall I reveal the solution? Yes. Now 23 you take and here 14 you take. Now where we'll start with, where many of you would have written 23 is equal to 2 into 11 plus 1. How many of you written like this? Correct. Now some of you would have written like this. 23 equal to 3 into 7 plus 2. Correct. Some of you would have written like this. 4 into 5 plus 3. Okay, like that you can write how many times? Up to 23 we can write. How many times you can write? Up to 23. 23 divides 23 one time and 0 remainder. And 23 is, suppose if it is divided by 24, at that time 0 times it divides and 23 is the remainder. That's how it will go. Okay, so like this, any number can be written in the format of A is equal to B cube plus R. This is very, very important thing that you have to learn. Are you understanding? So 23, not only 23 times, he can write infinite number. Suppose if I want to write 23 to be divided by 115, say. Can you not write it? Yes, we can write 23 is equal to 115, 0 times, and what will be the remainder? 23 will be the remainder. So like that you are taking all the numbers into consideration, correct? So this is very, very important fact that you have to learn in this chapter. Is it clear to you? Now let us go to 14. See, we have chosen some selected numbers, but it doesn't mean that it will end with that. Any number we can bring it to this format, which is the first learning in this chapter. With about that, using that we will be working out sums. Is it clear to you? Now next 14. How do you write 14 as? 14 is equal to 1 divides 14, 14 times plus 0 remainder. 14 divides plus, can you do like this? If suppose if I want to divide 2, so how many times it divides? It's only dividing 7 times. So 0 remainder, correct? Now 14, suppose if I have to divide, so what number will fit here? 4 times. 4 3s are 12 plus 2 remainder. 14 can be divided by 4. 4 into how many times? 3 times. Then again 2 remainder. So like that we can continue like that. To how many number of times? Infinite number of times we can write. Suppose if it is going to be divided by a number which is going to be greater than this 14, what will happen? It will divide 0 times and that 14 will be the remainder. So that is how the lemma is to be understood. Is it clear to you? Now I am going to give you a puzzle which you have to solve and keep it ready for the next session. Okay. Once, an old man was selling eggs and going. Okay. So on the way, there was another fellow who also came in the hot sun searching for some water, or he lost his way or some problem. He happened to hit against this old man, and because of that, the seller who was carrying eggs in his basket fell down and all the eggs were broken. Okay, he was in tears. Then both of them went to the king. The king asked, "What is that you want? How many eggs were there in your basket, so that I can ask him to compensate for the loss?" Then the egg seller replied, "My basket cannot hold more than 150 eggs. So, if I divide the number of eggs by 2, 1 remainder. If I divide the number of eggs by 3, 2 remainder. If I divide the number of eggs by 4, 3 remainder. If I divide the number of eggs by 5, 4 remainder. If I divide the number of eggs by 6, 5 remainder. But if I divide the number of eggs by 7, no remainder." Then everyone was, breaking their head to get the correct number. I want you to try this, and tomorrow you should, or the next class you should come out with the best answer, and I want to know how you got it. Again, using Euclid's division lemma, you should write and show it to me. Till then, all the best. Happy trying. We'll see in the next session.